welcome to channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your chemistry class, that is your class for 13th class of the session, where we had completed your 12th class in the last session, and that we are continuing with the unit 10, which is haloalkanes and haloarenes. We had done your last units here. So let's get started with the same. We discussed about the retention here, that has also been the important one. So here we go. Unit 10, haloalkanes and haloarenes. So we go for the retention here. The retention part, that this is the third part. So the same way though for the retention of the configuration is the preservations of integrity of a spatial arrangements of bonds to an asymmetric center during a chemical reaction or transformation. It is also the configurational correlation when a chemical species S cape is converted into the chemical species Y cape, and that having the similar relative configuration. So that has been in general, if the during reactions no bond to be the stereo center that is broken, the product will have the same general configuration of the groups around the stereo center as that of the reactant. Such a reaction is said to proceed with retentions of the configuration, and you have to consider an example, that the reaction that takes place when 2-methyl butane 1-ol is heated with concentrated hydrochloric acid. Now we go for the one. So just write it down. For the retention here, the retention of a configuration of a spatial arrangement of bonds to an asymmetric center during chemical reaction or transformation. It is also the configurational correlation when the chemical species X C A B C is converted into the chemical species YCABC having the same relative configuration. Now that the reaction we have for the following, it has been A C X B A Y X been here, Y been inserted, B, and this is C. So in general, if during a reaction here no bond to the stereo center is broken, the product will have the same general configuration of groups around the stereo center as that of the reactant. Such a reaction is set to proceed with retentions of the configuration, and consider as an example that the reaction that takes place when 1,2-methyl butane 1-ol is heated with concentrated hydrochloric acid. That is the reaction we have. CH3 CH2 H CH2 CH3 OH plus HCl in the presence of heat, H CH3 CH2 CH3 CH2 Cl plus HOH. This is two methyl butane 1-ol, and this is 1-chloro 2-methyl butane. Now we talk about for the another one, that is the fourth one, is your inversion, retention, and racemisation. That is comes under in it, and which I will discuss here one by one. So in detail about racemizations and all these things that we have done here. So let's go for it. The fourth one is inversion, retention, and racemization. So here there are the three outcomes for a reaction at an asymmetric carbon atom. We have to consider the replacement of a group X by Y in the following reaction. So here we go. There are three outcomes for a reaction at an asymmetric carbon atom. Consider the replacement of a group X by Y and the following reaction, that is C2H5 CH3 H by C2H5 H CH3 A plus B. Y C2H5 H CH3 A. So here the reaction, here if A is the only compound that obtained, the process is called retention of configuration here, and if B is the only compound obtained, the process is called the inversion of the configuration. And if a 50 plus 50 mixture of the above that two obtained, then the process is called racemisation, and the process is optically inactive and as an isomers with rotate light in the direction opposite to the another here, that is comes under in it. Now we go for the detail another here, that is how now let us have a fresh look about in the same phase that what we are going to deal with the fresh look of SN1 and SN2 mechanism, that taking an example of optically active alkyl halide here. So in the case of optically active alkyl halide, the product formed a result of SN2 mechanism that have an inverted conversion as company to the reactant, and this is because of the nucleophilic attached itself as a site opposite to 1, and where the halogen atom is present, and 2-bromo-octane that is allowed to react with sodium hydrox and octane 2-ol is formed with OH group, and that occupied the opposite to what bromide had occupied. So which is the same, the reaction we have. Plus OH, it will give OH H CH3 C6H13 plus Br. This is the here Thus, the SN2 reactions of optically active halide are accompanied inversions of configuration. In the case here, in case of optically active alkyl halide and SN1 reaction that accompanied by the racemization, then you think of the reaction that happens in actually the carbocation that formed in the slow step and being hybridized in the planar, which is achiral. The attack of the nucleophile may accomplished from either side, that resulting a mixtures to the product having the same configuration and the OH attaching to the same post of an halide ions, and the other having an opposite configuration, and that the attaching to the side opposite to halide ion as well. This may be the illusions of hydrolysis of optically active to bromobutane, and which results in the formations of plus butane to all, and that is the reaction which we'll be considering further here. So let's go for the same, and that the reaction that we are going to deal here. In this, if you see to it here, I will just write it down for the next one for the reactions here that has been taken the place. CH3 Br H CH2 H3 hydrogen CH3 plus CH2 CH3 plus Br minus. Here this is the reaction. So further we have CH3 H CH2 CH3 OH minus CH2 CH3 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 OH CH2 CH3 H. So this is your plus butane to all, and this is butane to all. Now we talk about for the elimination reaction. So for that, elimination versus a substitution as well, that we deal here. But for the elimination reaction we have, this is the important one, the elimination reaction as well. So as I've gone through with the same, we will be discussing in the detail in the next coming class. I just give you some of the questions related to it, so that if you are able to solve, you can solve it out, and if you are not able to solve, you can just tell me on the comment section. I will be providing you the soon. So the question is, question 7 that we give here in the as an homework. Which alkyl halide from the following pairs would you accept to read rapidly by an SN2 mechanism, and explain your answer? That is the question here. So you have to answer it out. So the question is, which alkyl halide from the following pairs you expect to react more rapidly by an SN2 reaction mechanism? Explain your answer. So we are the same, we go for it. The first we have CH3 CH2 CH2 CH2Br, or CH3 CH2 CH3. So here it is Br. The second is CH3 CH2 CH3. It is Br, or CH3CBr, CH3, and this is CH3. The third one we have CH3 CH2 CH2Br. This CH, we have CH3, or CH3 CH2 CH2Br. This is CH3. So let's go for the same, and that is you have to solve by your side, and that we continue with the next one with the elimination reaction, and that is on 13th class of the session, and the 14th class of the session that we discussed. So thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you.